Installing turnout motors is in principle fairly straightforward, and in fact for most of the motors on my layout that was true. Really all you're doing is you're basically placing a motor that slides back and forth with a pin up into the throw bar, where that pin can now shift the throw bar back and forth in order to actuate the turnout. MTB turnout motors have a few different points of adjustment that are actually quite important for a successful install. One of those is the throw length. There are 4 different options for this, and it's important to consider which one to use in order to start out with installing these motors. For N-scale layouts like mine, there is a 3mm difference between the points and the adjoining rail. And so setting the throw length to 3mm is probably a good default here in order to start for motor installation. There are also a couple of other variables to consider during installation. One is the choice of pin. The MTB motors come with a fairly stiff steel pin that can be used to actuate the turnout points. These actually come in handy during certain types of installs where you really need to make sure that the turnout points shift over. The other is to use music wire. This offers a more flexible solution that in some cases came in handy for my installs, particularly if I had to make a bent shape where I couldn't actually position the motor directly over the pin insert hole, or where I just needed to compensate for a little bit of slop in how the motor ended up having to be installed. As you can see, it is a little bit more flexible, and so that offers you a little bit of literal flexibility. In addition, this slider that is used to actuate the turnout points can actually be shifted in terms of where it starts. This also offers some additional flexibility in making sure that the turnout motor starts and stops at a point that is best suited to actuate the turnout. The real challenge when installing turnout motors is when space is constrained and there's not an ideal way to actually install the motor directly below the hole where the pin is supposed to go. Well, that is the case for the 2 turnout motors that are right in front of the layout, where there's not enough space on any side to actually have the motor mounted directly over the pinhole. So here what you can see is that I'm starting to rig up an alternative for how to actually place the pin. And in this case, what you can see is I'm also just trying to figure out where best can I put the turnout motor, given that I'm right close to where the DCC chip is, and also right close to both the fascia and one of the horizontal supports. So in this case, the goal is going to be to make essentially a double L-shaped pin where one end can actually actuate the switch, and then the other end is attached to the motor itself. This way, when the motor slides in one direction, it pulls the entire assembly down away from the front of the layout, and when it switches the other way, it pushes it back too. So this is where that music wire that I mentioned in the previous video becomes really important, because unlike the very stiff pins that come with the MTB motors, this is flexible, and so I can use a pair of pliers and some benders in order to actually shift it into a couple of right angles. And so here you can see the finished product. You notice it looks a little bit like a stair step. One end goes up into the hole for the pin, the other end goes into the turnout motor. Well, we'll give this a shot and see how well it works. So first things first is to actually attach it into the motor, and as you can see, this way when the motor slides forward, it will actuate the switch in one direction, and when it slides back towards the back of the layout, it'll go towards the other. And here you can see the placement that I'm intending. So first things first is simply to make sure that I've got the pin in place and can actuate the switch. Now I'm marking where I actually want to drill to install the screws to hold the motor. This is altogether a tight fit, there's no getting around it. But nonetheless, you can see where the advantage of having a low-profile motor becomes important in a case where there is no real way that I'd be able to easily put a tortoise motor. Now drilling the holes, making sure that I don't drill too deeply. Again, these are pilot holes, I'm not trying to drill through the layout. And now, 4 screws to actually install the motor. Let's actually get some DCC power on board. Once again, you can tell space constraint here is rather substantial. We'll get this wired down into DCC bus 2. That is where all of the power for turnouts will be sent from. Now I'm pressing the program button. As you can see, after about 5 seconds, the LED comes on. This allows me to program the address for the accessory into the DCC system. And as you can see, at this point, now I'm testing to see whether I've actually got good actuation of the turnout. And in this case, everything actually looks pretty good. I can see a complete movement of the turnout points from one side to the other and back. Not every installation works exactly like that on the first try. Here's another complicated install where I needed DP4 in order to fit an even more confined space. Now the good news in this case is that I can have the motor actually right above the hole where the pin will go. So that's the good news. The not so good news is you can see precisely how little room there is on any side of the switch motor in order to actually make this happen. So once again, here is the install process. In this case, the DP4 has 2 ears to accommodate 2 screws, and that's what will anchor the motor down to the base of the layout. Once again, using a jeweler screwdriver to press the small test button that will allow me to program the motor. There's the steady glow of the LED, and so time to add the accessory number for it. Once the switch is programmed, first thing to do is to run it and see how we're doing. As you can see, the motor itself is actuating. However, it doesn't seem to be sufficient for the points to actually be moving. So the first thing I'm doing is I'm unscrewing and loosening the adjustment slider on the front of this switch motor. This is the first way that I try to see if I can reposition the start and stop point of the pin in order to get the turnout to actually move. As you can see, I'm actuating the turnout points themselves in order to see whether or not I've got this slider in the correct position. With the slider on the front of the motor repositioned, now it's going to be time to retest everything and see if I've actually got a better actuation of the points than I had before. So let's throw the switch, see what happens. And no joy. My concern at this point is that the reason this switch isn't actuating is because the flexible music wire pin here might not actually be enough force to move the motor against its spring. I've decided to leave the internal springs into the turnout points simply because that provides a way to make sure that once the switch is thrown, it latches firmly against the other rail. So here my strategy is to remove the music wire and to actually use the thicker pin that comes with the turnout motor itself. That might be a way to exert a little bit more force by having a much less flexible pin. It's why you shouldn't necessarily get rid of that thicker pin. It might actually be useful to you. So now it's time to put everything back together. Here what you can see is I'm securing the pin and its manifold back into the front of the turnout motor. And now we'll do a test. Let's see whether or not we actually have a better outcome. It's sort of funny, in many ways, setting up these turnout motors means having a habit of mind towards experimentation and simple troubleshooting. Fix one thing at a time, see what you get, and then fix another thing. And if you do so in an orderly way, then it's much easier to make sure that you get the outcome that you're looking for. In this case, I've gone back to trying to readjust the position of the slider in order to see whether that will make the turnout points actuate correctly. It seems that we're doing better, but again, a little bit more adjustment is warranted. I'm getting the turnout points to move firmly against one of the sets of rails, but not quite the other. I spend about another minute and a half working with that slider to see whether I can get everything to sit correctly. And, still not quite working. At this point, I've tried to work with the slider position, and I've also tried to work with the pin. This leaves the throw length as being the other variable to try to work with. So, since I've got this currently set to a 3mm throw, the next variable is to set it to a 6mm throw and see if that's enough to get the turnout points to move against the other rail. Alright, I've gone back, opened up the switch motor, and reset the pin from a 3mm to a 6mm throw length. At this point, that seems to be the biggest variable to change, so I have a good feeling about this. Once again, reinstalling the motor into its position, and then we'll go ahead and throw the switch and see what happens. Alright, moment of truth, let's do it. Looks good in one direction, and actually looks good in the other. So in this case, taking a systematic approach to the turnout motor calibration actually led to a good outcome. It took me about 30 minutes total for this particular switch motor install, which really isn't too bad. And here you can see the turnout in question. Not bad. So there are some key lessons to learn about installing turnout motors like these. Number one, no two installations are alike. There were multiple points at which I had a similar style of installation, in other words, just putting the motor directly above the place where the pin should go into the turnout throw bar, and yet I still had to make adjustments that I didn't have to make elsewhere. This simply means that for each installation that you do, you want to make sure that you systematically approach each variable that might be responsible for not having the motor throw the turnout in the optimal way. For MTB motors, again, there are just a couple of key things that you can adjust, but most of this seems to take care of all the problems that I found. Number one is adjusting the throw length. I always started with 3mm because that is considered to be the optimal throw length for an N-scale turnout. Number two was adjusting the start point by adjusting that slider that I showed on the pin manifold. And number three is using music wire or using the solid pin. Both of those have their advantages and their drawbacks. Ultimately, by addressing each variable one at a time, I was able to do 9 successful installs pretty much within the space of a few hours. Nothing took too long, even the most complicated install that you saw here. Well, I hope that provides a little bit of insight into my process for installing these MTB motors. Since installing them, all of them worked actually quite well, and the last thing I needed to do was simply to adjust the amount of pin that was showing up through the top of the layout to make sure that there were no obstructions to the trains operating above. Next time, we'll talk about wiring signals into these motors. Alright, with all that done, hope you have a great rest of your weekend. Take care.